Good morning, students. Today we are starting with the next chapter, Chemical Bond, class 11. Why atoms form bond? That is the first prior, thing comes to our mind. Why the atoms form bond? They form bond to achieve stability. When we were writing the configuration, we have seen that the noble gases are very stable. Noble gases are very stable. That means they have octet configuration. We said they have octet configuration. Octet configuration means they have 8 electron in the valence shell. We know in the noble gases the general configuration was Ns2Np6, except for helium. Helium was having a duplet configuration of 1s2. Rest all are having 8 electron configuration. Okay, that means every atom tries to get octet configuration. That is the initial, thing which was there in the mind, that every atom is forming bond to achieve stability. But later on, this was also explained on the basis of energy. On the basis of energy it was discussed. Because see, when atoms are far away from each other, when they are very far from each other, let's say infinite. Infinite for atom means since atom itself is so small, so that means nearly 100 centimeter will be, infinity for atom. So if they are quite far away from each other, then there are no forces of attraction or repulsion between them. But when they start coming closer, the attractive forces start increasing. At one particular point, the bond is formed, then the energy becomes minimum. Now actually this we can explain on the basis of this graph you must have seen many a times between the potential energy and R. R is the distance between the atoms. So when they are this type of graph, children, you must have seen something like this, you got it. So at infinite distance, and this is a infinite distance, at when R is distance, this is R between two atoms. Between two atoms, this is the distance R. So if it is infinity, means they are very far from each other, then the potential energy is zero. It is considered to be zero. Okay. When they come closer, means when the distance between the two atoms decreases, they come closer means what is happening to the potential energy? Potential energy is decreasing. This is the minimum. So this is that point where the bond is formed between the two atoms. So this distance between the two atoms, this is represented at bond length. When the potential energy between the two atoms is minimum, then we say the bond is formed between the two atoms. That means they have acquired stability. Okay, this is the minimum potential energy. So at minimum potential energy, what is the distance between the two atoms? This is called as the bond length. Further you bring them closer, further you try to bring the atoms closer, what is happening? The potential energy starts increasing. That means the repulsive forces, act on the atoms, and then the potential energy becomes more. So we say that the potential energy is inversely proportional to the stability. Actually, you say energy itself. Energy and the stability are inversely related. It is said that every system in the universe tries to be stable. And to get stable, the energy is less. Okay, even human beings. Any system in the universe tries to acquire minimum energy. And when they have minimum energy, we say they are stable. That means when atoms were far away, they are unstable. Potential energy is there. It is considered to be zero. Beyond that, when they start coming closer to each other, they come closer. When they start coming closer, attractive forces increase. Maximum attractive forces are at this point where the potential energy is minimum. So at this point, what is the distance? The bond length, the distance between the two atoms. This R represents the distance between the two atoms. So when the potential energy is minimum, what is this value? That is called as the bond length. Further you start bringing them closer, they will, the potential energy will start increasing. That means we will say the atom has, the repulsive forces are there now. It becomes again unstable. Repulsive forces become greater than the attractive forces. So mainly two forces are acting between the two atoms. Okay, so this is, we have discussed what is the cause to form a bond. Okay, now we will discuss how many types of bonds are there. We'll see types of bonds. On the basis of how the bond is formed between the two atoms, it is of various types. You have the first one as ionic bond. Ionic bond, children, is also called as electrovalent bond. We will discuss about each type. Electrovalent bond. This is first type. The second type is covalent bond. Covalent bond. Okay. The third type is coordinate covalent bond. Coordinate covalent bond, which is also called as dative bond. Coordinate covalent bond is also called as dative bond. Okay, so now in today's video we will be talking about ionic bond. Okay, now what is ionic bond? So first time consider as metallic bond also between the metal atom, but that we normally discuss in class 12 solid state chapter. Right, we are talking about ionic bond. What is ionic bond? Ionic bond is formed by transfer, by we can say complete transfer. It is formed by complete transfer of electron from one atom to another. From one atom to another. One atom loses the electron to another atom, and it will result in the formation of cation and anion. Let us consider. Say I am talking about the very common example, children, NaCl, which we normally consider as the example for ionic bond. NaCl. Now how is NaCl formed? It is formed from Na and Cl. So what happens is Na in the gaseous state. We have been discussing ionization, electron gain, enthalpy, everything in the isolated gaseous state. So this is isolated gaseous atom of Na. The configuration, children, when we write is 281. That is in the lower classes you were writing like this. Otherwise we write 1s2, 2s2, 2p6 and 3s1. That means in the valence shell it is having one electron. So that means it can lose this one electron and it will get octet configuration now in the valence shell, because the third shell 3s orbital will lose electron. And it will result in the formation of Na plus also in the gaseous state. Also in the gaseous state. And there is Cl. Cl configuration we have written as 1s2, 2s2, 2p6, 3s2, 3p5. It is having 7 electrons in the valence shell. So that means it needs electron. In the previous case, 1 electron was also lost. Okay. Now this is the first step, children. This is the second step. This is in need of 1 electron. So the electron which is given by Na is taken up by Cl. And it will result in the formation of Cl minus also in the gaseous state. Okay. Now this is Na plus in the gaseous state, Cl minus in the gaseous state, and now it will be the third step where between Na plus in the gaseous state, Cl minus in the gaseous state, they combine and result in the formation of NaCl. This NaCl now is in the solid state. This is in the solid state now. Got it? Now let us see what are the steps taking place in this. This is the formation of ionic bond, children, we have taken. Now what is there here? Na has lost electron. What is the energy involved in this, children? It is positive because it is required endothermic plus ionization energy, we say. It's positive ionization energy. Second step, what we are saying, this is gaining electron. This is gaining electron and it is added in the valence shell of the neutral isolated gaseous atom. So what is energy? It is liberated energy. It is electron gain enthalpy, or also called as electron affinity. It is released energy. Next step, cation and anion, between them there is force of attraction. So whenever there is a force of attraction, children, energy will be liberated. To break a bond, energy is required. To form a bond, energy will be liberated. It is liberated energy. So minus we are representing for liberated. And this energy is called as lattice energy. This is lattice energy. Now, lattice energy is the energy released in the formation of 1 mole of the ionic crystal from oppositely charged ions. Between the oppositely charged ions, there will be some force of attraction. So in that process, the bond is formed. Electrostatic force of attraction develops between the cation and anion, which results in the liberation of energy. That is called as lattice energy. So what can we say? In the formation of the ionic bond, there are 3 steps. Which 3 steps? First step is formation of cation. What is the first step, children? First step for the in the ionic bond formation is formation of cation. Cation is formed. Neutral gaseous atom loses electron and it results in the formation of Na plus. Electron is liberated, energy is required, ionized. So formation of cation is the first step. Okay. Next, the neutral atom, that is a non-metal. The one that is losing electron is a metal. Okay, that is another very important thing for the ionic bond. Ionic bond is always formed between a metal and a non-metal. See here, this ionic bond is always formed between what? Between a metal and a non-metal. Ionic bond is formed between a metal and a non-metal. Metal loses electron, non-metal gains electron. That we have discussed in the periodic table, that the metal can lose electron readily and non-metal can gain. So what is the first step, children? Formation of a cation. By what? Formation of a cation by a metal. You can further specify this. Metal will lose electron, will form a cation. Energy required is ionization enthalpy. Next step is formation of anion. Anion by a non-metal. A non-metal gains the electron which was given by a metal and it results in the formation of the anion. Non-metal can gain electron because non-metals are present on the right hand side of the periodic table. They are smaller in size. For them, gaining electron is easy. Metal is present on the left hand side. They can lose electron readily. Their size is big. Okay. So energy liberated is electron gain enthalpy, or you can call it as electron affinity. The last step, association between cation and anion. Between cation and the anion which were formed here, there is association, force of attraction. In that process, energy is released. That is called as lattice energy. So what we have discussed, children, here? First, we have discussed what is an ionic bond. It is formed by a complete transfer of the electron from one atom to another. From which atom? Metal to another. Another means non-metal. And then we have, what are these 3 steps? These are the steps involved in the formation of ionic bond. Steps involved in the formation of ionic bond. Children, there are 3 steps involved in the formation of ionic bond. Formation of cation by a metal, formation of anion by non-metal, association between cation and anion. In the formation of cation, energy is ionization. Formation of anion, energy is electron gain enthalpy. And in association between cation and anion, the energy involved is lattice energy. Here itself, one more thing what we can discuss is the formation of the cation by metal. When we are saying, what are the favorable conditions for the atom to form a cation? We can talk in terms of size. Size should be big. Bigger the size of the atom, atomic size, if it is big, it can lose electron readily. In terms of ionization energy, what we can write? Ionization energy should be low. Lower the ionization energy, easily it can lose electron. Now, in terms of electron gain enthalpy, that is the second factor. This was the first factor, this is the second factor, this is the third factor. In the second factor, we are saying formation of the anion. Formation of anion will be easy if the atomic size is small. Smaller the size, easily it can gain electron. In terms of the electron gain enthalpy, in terms of electron affinity or electron gain enthalpy are same. We can say the electron gain enthalpy should be high. High means more liberated it should be. Got it? So size should be small, electron gain enthalpy should be high. Next, lattice enthalpy. Lattice enthalpy is the energy released when between cation and anion, there are some forces and solid is formed. So if you want to define what we can write for lattice energy, energy released in the formation of 1 mole of the ionic solid from oppositely charged ions. If you want, you can also define lattice energy in terms of energy required. That means the reverse. To break 1 mole of the ionic compound into oppositely charged ions, what is the energy required? That is also lattice enthalpy. But since here we are talking about cation and anion combining, so Na plus and Cl minus, between them there will be some force of attraction. No bonds we will show. Just force of attraction I am just showing you. Between cation and anion there are forces of attraction. Okay, electrostatic forces of attraction between cation and anion, and this will release energy. That energy release is called as lattice enthalpy. Okay, as you say, there is a formula, children, you study that the force of attraction is directly proportional to Q1 Q2 by R square. Where what is Q1, Q2? Q1 and Q2 are the charges on cation and anion. And R is the distance between the two. So, if the charges are more, the attractive forces will be more. If the distance is less, attractive forces will be more. Very, very important, children. Please note it down. Force of attraction between cation and anion. Since we are saying there is electrostatic force of attraction between cation and anion, we will say the formula is it is directly proportional to Q1 Q2 by R square, where Q1 and Q2 are the charges present on cation and anion, and R is a distance between the two. See, ionic bond is not a bond. We'd never write Na and then we write like this bond between them. We just write the formula as NaCl. Have you noticed it? We never write Na-Cl. Like we do for covalent compound, but here we do not write. There is no bond written between these, because in ionic bond there is just electrostatic force of attraction between cation and anion. See, now we will see what factors affect lattice energy or lattice enthalpy. There are two main factors which affect lattice energy or lattice enthalpy. The first one is the charge on ions. Charge on the ions. We know that if the charge is high, that means if we are saying higher the charge on the ion, greater will be greater is the force of attraction. Greater is the force of attraction. When force of attraction is more, obviously lattice enthalpy is more. Lattice energy will be more. Higher the charge, greater is the force of attraction. We have already discussed if the charge is more, the size is small. Suppose you are asked NaCl, CaCl2 and MgO. Which one will have more lattice enthalpy? Let us see what charges they have. This is having plus, this is minus, this is 2 plus, and Cl is minus, this is 2 plus, and this is 2 minus. So here in this case, that higher charge for cation means smaller size, higher charge for anion means bigger size. So this will be the order for the lattice enthalpy. This is 1 uni, that is 1 negative. This is 2 and 1, this is 2 and 2. Higher the charge, more is on the ion the higher charge. That means for anion and cation both. In this case, both anion and cation were having the higher charge. So this will have the maximum lattice energy. What in terms of the size? Size of ions is the other factor which affects the lattice enthalpy. And we know that if the size is small, that means smaller the size, more is the lattice enthalpy. Smaller the size, more will be the lattice enthalpy. That means we can say this is directly proportional. More the charge, more the lattice. Here, small the size, more the lattice. That means we can say that the size and lattice enthalpy are inversely related to each other. Suppose you are asked a question, LIF and LII, which has more lattice enthalpy? LIF and LII. Li is common in both. Then we have to see the next one, that is halogen, which is smaller, F. So this has more lattice enthalpy. Got it? Let us consider another example, AgCl, AgI. When cation is constant, we have to see the anion. Okay, anion. This anion is bigger in size, so this one will have more lattice enthalpy. Okay, I hope you'll be able to answer this. See, we can explain ionic bond taking some more examples also. I have taken one example, that is NaCl. Now we will take some more examples. Say if I am taking calcium fluoride, how you can explain? We will write the 3 steps always. Calcium, if I write the valence configuration, means including that if I write third shell onward, let me write 3s2, 3p6, 4s2. This is the configuration of calcium. That means this is in the gaseous state, children, and this is having 2 electrons in the valence shell, so it can lose those 2 electrons and it will result in the formation of Ca2+. Now the configuration is 3s2, 3p6. Okay, so it has lost 2 electrons. Now if I write the second example, ion part, there are 2 fluorides. Okay, let me write with one and then I'll explain. This is say 2s2, 2p5. It needs 1 electron. So since calcium has given 2 electrons, so this 2 of them are required. So we can write 2f in the gaseous state can gain the 2 electrons and will result in the formation of 2f minus. There are 2 fluorines, each one taking 1 electron from here, and you will get 2f minus, and it will be 2s2, 2p6, that is stable configuration. And now in the third step, you can have this calcium ion and 2 fluoride ions. They both in the gaseous state will form CaF2 solid. What is the energy involved? Ionization enthalpy. What is the energy involved? Electron gain enthalpy. Here it is lattice enthalpy. Clear? The same thing, children, we can also write in terms of the Lewis dot structure. Let us take both the examples explaining using Lewis dot structure. Lewis dot structure. Sodium. We know in the valence shell it is having 1 electron. So we will show valence electrons by dot or by cross. The another atom was chlorine. Chlorine was having 7 valence electrons. So for just to distinguish, this I am represented with a dot and this one with cross. So this needs 1 electron. When it needs 1 electron, so it can be given to it. When this can be given to it, it will result in the formation of Na+. And this will have now 8 electrons itself and 1 electron taken from here. So this has got 1 extra electron from there. So now we can say, we can put this in the bracket also now. You can put this in the bracket and show this with the minus sign. Clear? So what was the configuration here? If you write that way, it was 2, 8, 1. And this was 2, 8, 7. Now this is having 2, 8. This is having 2, 8, 8. This is the Lewis dot structure. Okay. Quickly I will show for the next one also. Ca and then you have F. F is having 7 valence electrons. This is having only 2 electrons. So there are 2 separately we can show, because there were 2 fluorines involved. So 1 fluorine, this is giving 1 electron here. This one is giving 1 electron here. So this is getting 2 electrons from this calcium. So after that it will have Ca 2 plus configuration, and this I am showing them together. There will be 2 fluorines. Okay, there will be 2 fluorines, and now each one is having 8 electrons. Each one is having 8 electrons in the valence shell. This will be 2 negative. Between them there will be force of attraction between cation and anion. One important term, you can try out many examples using this. You can try it on your own, showing example of MgCl2. You can take example of Na2S. You can also try out one more example, taking calcium sulfide, or you can take say magnesium bromide or magnesium oxide. Any examples you can try writing all the steps, Lewis dot structure, and please write down in your notes copy. Right, one term which I will introduce here, that is electrovalency. There is one term we use, children. What is electrovalency? Electrovalency is number of the electrons lost or gained. Lost or gained means in terms of the metal we will say the number of the electrons lost, and in terms of the non-metal we will say the number of the electrons gained. For example, Na has lost 1 electron, so its electrovalency is 1. Cl has gained 1, electrovalency is 1. Don't say -1. It is just the number of electron lost or number of the electrons gained. Calcium has lost 2 electrons, so electrovalency of calcium is 2. Fluorine has gained 1 electron, electrovalency of fluorine is 1. Do not say it is -1 or +1. Electrovalency just indicates the number of the electrons lost or gained. Okay. I hope you liked the video. If you liked it, please like my channel. You can subscribe, and if you have any doubts, you can ask in the comment section. Thank you for watching.